Good morning, everyone. Mark here. Welcome to a log proof. Today we're going to prove that log base b of x is equal to log base c of x divided by log c of b. Now you probably see this to prove a theorem that states that we can go between logarithms just by dividing by the desired base. Okay, so nonetheless, let's get straight into it. First thing we want to notice is that we're a little bit all over. So if we want to set forth a proposition that may get us to naturally come up with this solution, right? First thing to do is to say, well, what if we said that log base b of x is equal to y? And if we can push y in the direction of equaling log base c of x divided by log base c of b, then if log base b of y is equal to y, and we were at the same time saying that y is equal to log base, well, if y is equal to log base c of x and log base divided by log base c of b, well, then they're equal to each other if we're able to push y into the direction from here, right? So that's what I'm going to aim to do, and let's get to it. So here's kind of the non-intuitive part, or a very intuitive part. When you're looking at this, you probably say, well, what this is really asking, it's saying, well, x is equal to y when b is raised to y to the yth power, right? That's really what this is saying, because when we look at logarithms, it's asking the question, right? Ooh, I did not mean to delete that b. This base raised to what power is equal to x? So simply, that's b to the y is equal to x. These two are equivalent, these two statements. So we've transitioned from this equality to, well, equality 1 to equality 2. Okay, just trying to be crystal clear. All right, so now that we've got that equality transitioned, there's one thing that I'd like to take note of, is the fact that we have a b to the y. And when you see b to the y, the intuition should be, if I take a log of this, we remember our log rule that states, well, log of some b of x to, let's just say, the y is equal to y multiplied the product of log base b of x. Simply just saying we're allowed to pull this down. It's acceptable, right? So if we take the log of both sides, we're going to be able to do that. So I'm going to take the log base c of both sides, because right now we've got a b and we're looking for a c in our equation. So that might help us get in the right direction. That's really the intuition. That's why I'm doing it. So why don't we just take the log base c both sides, and I'm gonna write it over here, log base c of x, and I'm gonna remove this x. All right, so I did not make anything new. I just took the log base c of both sides of the existing expressions there. Well, as we stated before, we're allowed to move the y down. So let's move the y down, which gives us y log c of b is equal to log c of x, right? And so now you probably already see it. I'm not sure about this blue color, let me know. But if we simply just divide by log c of b on this side and log c of b on this side, this is basically saying, well, not basically, it states that y is now equal to log base c of x over log base c of b. And so we're good. Why? We set y equal to log base b of x. And if we just plug y back in, when we look at this equality right over here, all we're really saying is that log base, that's not an e, that's a c, log base c of x divided by log base c of b is equal to itself, log base c of x divided by log base c of b. And so we're good. I hope that makes sense to you. It took me a little bit to pick up on the intuition and the kind of replace, substitute, and then drive it in the right direction, and then all of a sudden you see yourself at the correct, you see yourself there. Yeah, so let me know if you have any questions, if there are any inconsistencies or ways you'd improve the video. Thanks so much for watching. Bye now.